Apple's new A19 Pro chip and Arm's Lumex platform are pulling generative AI straight into your pocket. With neural accelerators baked into every GPU core and scalable AI silicon powering everything from wearables to flagship phones, we're staring at the next wave. Powerful, private, on-device AI. Much less reliance on the cloud.
But before we dig in, did you know that only 40% of you are following us across all socials? Come on, guys, hit that follow button and collect our episodes on pods.media. Your support means the world to us. Thanks.
Yeah, what's really fascinating here is how quietly, yet, profoundly, the very architecture of our personal tech is being reshaped. So in this deep dive, we'll unpack the specific technologies making this possible, explore why this shift matters so much for you, the user, and look at the exciting challenges that lie ahead. It's what many are starting to call the post-cloud computing era for consumer devices.
Okay, let's unpack that, this incredible shift. For years, right, when we talked about AI, it almost always involved sending our requests up to the cloud. Powerful servers, process them, send the results back. It felt like, sending a letter to a supercomputer just to get a quick answer.
Right, a bit clunky sometimes.
Exactly. But now, the core of this revolution is brand new hardware. We're talking about taking that supercomputing power, shrinking it down, tiny microchip inside your phone, processing AI tasks right there, locally, on your device. And here's where it gets really interesting. Two major players are driving this. So what are the specific innovations Apple and Arm are bringing to make this possible?
Yeah, you've hit on the crux of it. Apple and Arm are definitely leading the charge, but with slightly different approaches. Both really important for this on-device AI revolution. Apple, for instance, they're making big strides with their new A19 Pro chip. That's slated for the upcoming iPhone 17 Pro and the iPhone Air.
Okay.
And the critical innovation isn't just raw power, though there's plenty of that. It's the direct integration of neural accelerators into each GPU core.
Okay. So not just adding an AI part separately, but actually weaving AI capability into the graphics engine itself. What does that really mean for handling AI tasks?
It's a game changer. It means every single graphics processing unit, every core in that chip, is now also like a dedicated, super efficient mini brain just for AI. Think of it like a specialized coprocessor for AI, but woven throughout the whole graphics architecture. This allows for massive parallel AI computations right there on the device. Unprecedented scale, really, which means much better efficiency and speed for things like image recognition, complex language processing. And for all that power, especially under heavy AI loads, Apple's also debuting a new vapor chamber cooling system in the iPhone 17 Pro. That's a critical detail.
Cooling. Yeah, that makes sense.
Absolutely. Without effective heat management, all that on-device power would just throttle down pretty quickly, makes those neural accelerators less effective.
Okay, so that's a clever solution. You need the power, but you also need to keep it cool enough to actually use it. So Apple's pushing the edge with their integrated design for their own stuff. What about Arm? They're often like the unsung heroes behind so much mobile tech. How are they fitting in?
Arm is the other major player. Less visible to you, the consumer maybe, but totally foundational to the wider ecosystem. They're introducing the Lumex platform. It's designed to offer scalable AI muscle across a whole range of devices. Think tiny wearables all the way up to flagship phones.
Scalable.
Lumex is built on SME2-enabled ARM v9.3 CPUs. That's ARM's latest processor architecture. Big focus on performance and security, and these new Mali G1 GPUs. Mali, for those who don't know, is ARM's high-performance graphics processor family. And here it's specifically optimized for AI.
So let me see if I get this. If Apple's building the really high-performance custom sports car, Arm is kind of providing the engine design that can power a whole fleet, like different vehicles, compacts, SUVs, whatever.
That's a great analogy. Yes. Both are crucial to putting this AI power in everyone's pocket. And SME2, that stands for Scalable Matrix Extension 2. That's particularly interesting. It's super efficient at handling the complex matrix math that's basically the bedrock of a lot of AI computation.
Got it.
So when you connect the dots, what this all means is that AI capabilities that used to only live on huge, power-hungry cloud servers, they're now literally baked into your phone. A lot of the heavy lifting for AI tasks can happen right there in your pocket, not miles away in some data center.
That is a monumental leap from the cloud AI we've known. Okay, so what does this mean for us, the users? Beyond the tech specs, why should you really care that AI is moving onto your device? What are the tangible benefits we'll actually see?
Well, if we connect this to the bigger picture, it's not just about convenience, right? It's about fundamentally rethinking how we interact with and maybe even trust our devices. The benefits are pretty profound. First off, faster responses.
Less lag.
Exactly. Gone are those, laggy cloud calls. When AI features like advanced photo editing or real-time translation or smart assistant queries happen right on your device, there's no internet latency, no waiting for data to travel to a server and back. AI features will just work instantly. It makes interactions feel much more natural, more seamless.
I can definitely relate to that little pause with smart assistants sometimes.
Yeah.
Yeah, instant responses sound like a genuine game changer. What else? What makes it a pocket revolution?
Then there's tighter privacy. And this is huge today.
Yeah, for sure.
When your data stays on your device for AI processing, it massively reduces the risk of data leaks. Your personal photos, voice commands, biometric data, they don't need to be uploaded to some third-party server. Ever. Imagine truly personalized, intelligent assistants that know your habits, your preferences really well, but they don't share that with the world. It fundamentally changes the privacy calculation for consumer tech. Gives you a level of data sovereignty we've rarely had.
That is a huge reassurance, especially now with data privacy always in the news. Knowing your personal stuff isn't constantly being shipped off somewhere, that offers a lot of peace of mind.
Absolutely. And beyond privacy, there's offline functionality.
Well, right.
Your AI features will now work even without an internet connection. I mean, who hasn't been stuck somewhere, right? On a plane, remote area, subway, trying to translate a sign or dictate a note, and it just says no internet connection.
Oh, yeah, the worst.
That frustration becomes a thing of the past. This expands the usefulness of your device in ways we really haven't seen before.
That's incredibly practical. No more, sorry, I need the internet for that. And I'm guessing this also impacts, the economics of it all. Data usage.
It does. Another significant benefit is reduced costs. Moving AI processing onto the device means less strain on cellular networks, on Wi-Fi, less bandwidth needed. This can cut costs for both you, the user, maybe lower data usage, and for the network providers too. Less traffic to manage. It's kind of a win-win for infrastructure efficiency.
Okay, makes sense. But is there a trade-off? Does this limit the sheer amount of data that AI can access compared to the cloud?
That's a fair question. Yes, the cloud has virtually unlimited data access, while a device is inherently limited. So yeah, it feels like this is about optimizing the type of AI tasks that live on the device, the ones that benefit most from speed and privacy.
Gotcha. But I imagine this also unlocks totally new kinds of apps, things we haven't even thought of yet.
Exactly. This move unlocks entirely new AI-native apps that can run anywhere, anytime. Developers aren't held back by cloud latency or connectivity issues anymore. To put this in perspective, imagine an AI that literally watches how you edit a photo. And then without you asking, it automatically generates 20 different highly stylized variations for you using your aesthetic preferences.
Whoa.
All happening instantly, privately, right on your device. That kind of real-time, personalized, always-on creativity. That's the true frontier this unlocks. It's a complete reimagining of what a smart device can do, moving beyond just reactive tools to become proactive, intuitive partners.
So the why is clear speed, privacy, accessibility, totally new apps. But these kinds of big leaps don't just happen, right? Who are the titans really making this happen? And what kind of digital mountains do they still have to climb to bring this future fully into our pockets?
You're absolutely right. Every revolution has its architects and its obstacles. So key players. Apple is definitely leading the charge on the consumer side. They're driving the rollout with the A19 Pro in their flagships, making a very public statement. On-deviceai is their immediate future, setting a high bar.
And Arm, the silent enabler, as you put it.
Indeed. Arm is that crucial silent enabler. They provide the foundational Lumex architecture. And that's not just for Apple's, closed ecosystem. Other major silicon providers, Samsung, Qualcomm, MediaTek, they're all building their own AI chips on Arm's underlying designs.
Okay, so the whole ecosystem relies on them.
Pretty much. So while Apple shows what's possible in their devices, Arm provides the blueprints, the underlying tech for the entire Android world and beyond. Collectively, these players are pushing the whole mobile ecosystem towards, let's call them, local AI-first experiences. It's a unified shift across the industry, not just one company's vision.
That's a powerful combination. But even with all that momentum, there must be some significant challenges, right? What are the biggest hurdles they're facing?
Yeah, this raises an important question. The promise is huge, sure, but the implementation, it needs serious innovation, adaptation across the whole tech ecosystem. It's not just about building powerful chips. It's building them efficiently, flexibly, especially for this rapidly changing AI landscape. The most immediate challenge, I'd say, is energy consumption and heat management.
Right. Back to the heat problem.
Yep. Even with Apple's fancy new vapor chamber cooling we talked about, the sheer computational load of these advanced AI models generates a lot of heat and drains batteries fast. keeping devices cool, making sure you get all-day battery life while running complex AI locally. That's a constant balancing act engineers are still wrestling with.
I can definitely see that. Packing neural accelerators into every GPU core sounds impressive, but yeah, sounds power hungry too.
It absolutely is. Another big hurdle is developer adaptation.
Getting the app makers on board.
Exactly. For these on-device AI capabilities to really shine, developers need to retool apps and frameworks to fully use this new hardware acceleration. What that retooling looks like, it's fundamentally new APIs, new ways of thinking about app design, maybe new programming paradigms to really leverage that local AI power. It's a learning curve for the whole developer community, moving from cloud-centric thinking to device-centric AI development.
So the hardware is ready or getting ready, but the software side needs a complete rethink to catch up and really use it. And what about AI itself? The models change so fast.
That brings us to the obsolescence risk. AI models are evolving at, frankly, an astonishing pace. What's state-of-the-art today could be outdated next year. This raises the concern that today's chips risk becoming obsolete if they can't flex to future demands. Chip designers have to build in a significant amount of future-proofing flexibility into their silicon. To handle AI models that haven't even been invented yet, it's a race against time, not just for raw power, but for adaptability. It's a fascinating challenge for chip architects, really.
That's a really thought-provoking point. It's not just power, it's future-proofing against AI's own unpredictable evolution.
Okay, looking ahead then, how quickly can we expect this on-device AI to become, standard? And what kind of devices will it spread to beyond just our phones? Are we really on the cusp of a post-cloud era?
Well, what's fascinating is that this isn't just another spec bump for your phone. It really feels like a paradigm shift, and it's happening fast. This isn't some distant future. We can probably expect on-device AI to become standard within the next 12 to 24 months, maybe even sooner in high-end devices. It's moving incredibly quickly.
Wow, okay. That soon.
Yeah, and it's not just a smartphone thing either. We're going to see this device expansion from smartphones to wearables, AR headsets, tons of IoT devices. Imagine your smart home stuff having localized intelligence, right? Making decisions based on your real-time behavior without sending data constantly to the internet. Or smart glasses offering real-time private AI help without needing the cloud. So our smartwatches get even smarter. AR becomes much more immersive because the AI is right there. No server round trip needed. That is exciting. But what does this mean for the cloud? Does it just go away?
Not at all. The cloud's role evolves. It'll absolutely remain key for training massive models. Think about those huge foundation models. They need immense compute power, vast data to learn. That still happens in the cloud. But once those models are trained, they can be optimized, kind of shrunk down for efficient inference, that's the day-to-day use locally, on your device. So the cloud becomes the training ground, the factory maybe, and your device becomes the personal, always-on AI assistant using the results.
Okay, so it's more like a collaboration, but with a big shift in where the daily AI work actually happens.
This really marks the start of what we're calling a post-cloud era in consumer computing. It's defined by fast, private, and always-on intelligence built into the device. It's redefining how we use technology, fundamentally moving power from those big server farms directly into our pockets. You could call it AI-first computing, maybe decentralization without the blockchain, but either way, the battleground has officially shifted to your jeans pocket. It means a more personal, more immediate, more private relationship with tech.
What an incredible deep dive. Seriously fascinating stuff happening right under our noses, or rather, in our pockets. From Apple's A19 Pro with its clever cooling, to Arm's scalable Lumex platform enabling the whole ecosystem. It's clear on-device AI is bringing us faster, more private, always-on intelligence. We've seen how it enhances daily interactions, cuts down cloud reliance, and still faces some really interesting challenges. Thanks for walking us through all that.
Yeah, this move really underscores a fundamental change. It's more than just specs. So maybe it's something for you, the listener, to think about. If the most powerful, most personalized AI is no longer a distant server, but an extension of your own device, always there, always private, what new possibilities does that unlock for your creativity, your privacy, your autonomy in this connected world? What could always-on private intelligence truly mean for your daily life? And maybe what new responsibilities come with that kind of power?